Today we will be solving the EOT for Physics 10 General for term 3. I haven't made this file, so whoever has made it, thanks to them, I will be using it. So these are the lessons. Most of it is remote, like projectile motion and relative motion. They are in enrichment. We will be mostly focusing on circular motion, related to which is planetary motion and gravitation, and using the law of universal gravitation. Most of these are the equations which we will be using, but we'll learn how to use which equation and at what particular time. Mostly they will be given to you in the question paper as well. Now we have in total 19 questions, out of which 15 questions are MCQ, that is electronic, as you're already familiar with, and 4 questions are writing, that is free response questions or FRQ, where that is worth of 40 marks and the 15 questions are worth of 60 marks. So basically you have 15 questions, 4 marks each, that gets 60, and then you have 4 questions which are 10 marks each, that gets 40, and in total you have a 100 mark paper. This is the writing part and this is the multiple choice option part, MCQs. Okay, moving to the first question. The first question says, define uniform circular motion. So when we say define uniform circular motion, we are talking about that something is moving in a circle. So say for example, like this is a stick. If we assume this is a particle and we start moving it in a circular path, so therefore this is a circular motion. But when this circular motion will be uniform? If the motion of this around the circle is with constant speed. That means the speed of this particular object is not changing. Only the speed, remember. So when we say uniform circular motion, we mean that the motion of a body along a circle in which the speed of the object or speed of the body is not changing or it is fixed. For example, consider this situation. We have a circle in which there is an object which is moving around, going here. It is moving here with speed v1, here it is moving with, okay, here is the point. When we say uniform circular motion, the value for v1 and v2, for example, if v1 is 10 meter per second, this v2 would also be 10 meter per second. It cannot change if it is uniform circular motion. But as it is a circular motion, obviously the direction of the velocity will keep changing. And if the direction of the velocity will keep changing, therefore the system will have some acceleration. So even when the object when the object is not changing its speed, it is fixed speed or constant speed, the direction is changing, so therefore there will be some change in the velocity. That means the velocity is changing, and if the velocity is changing, therefore the system has some sort of an acceleration. So be it any circular motion, be it uniform or non-uniform. When we say uniform, constant speed. When we say non-uniform, variable speed. Uniform circular motion, generally represented with UCM, is constant speed. Speed is not changing. But when we say non-uniform circular motion, then we say speed is varying. In both these cases, there will be acceleration. Here, there will be something called centripetal acceleration, which we will talk about and we have talked about in the class. And when varying speed, there is centripetal acceleration and there is an extra acceleration, which is the tangential acceleration, which is changing the speed of the body. So simple question, uniform circular motion, a circular motion in which the object is moving at a constant speed. Okay, moving on the second part. Page 143 and practice problem 13. Page 145. Okay. Relate the centripetal acceleration to the object's speed and the radius of the circular path. So we have an expression for the centripetal acceleration. What is that expression? That if there is a body which is moving in a circular path, and let's say it is going here, and it is uniform circular motion, that means the speed is not changing. So the speed is fixed everywhere, only the direction is changing. And the radius is r. So we define the centripetal acceleration which is acting towards the center of the circle. So the centripetal acceleration, because it is pulling it towards the center, this is called AC. This centripetal acceleration is given by v square over r, where v is the speed or the velocity you can say, and r is the radius. And what is the direction of this centripetal acceleration? So towards the center, because the object is being pulled consistently or constantly towards the center. Only then the object can move in a circular path. Okay, because it's something like this. Imagine this is an object, like this is a path. An object wants to go here, but a force is pulling it here. So the object wants to go in this direction, the force is pulling here, so the object will take a turn. It will come here. Now the object wants to go in this direction, but the force is pulling it again towards the center, so it will take a turn again. It wants to go here, but the force is towards the center, so it will pull it back and it will keep moving in the circular path. We have discussed this in the class. The question, an airplane traveling at 201 meter per second makes a turn. What is the smallest radius of the circular path the pilot can make and keep the centripetal acceleration under 5 meter per second square? So they have given us the acceleration, which is 5 meter per second square. They have given us the speed 201 meter per second, that is the velocity. What is the smallest radius of the circular path in kilometers? That means I have to find my answer in kilometers. The pilot can make and keep the centripetal acceleration same. So it's a simple question. I have the equation AC is equals to V square over R. I have been given the velocity, which is 201 square. I have been given the radius as well. No radius, I have been given acceleration, which is 5 meter per second square. I need to find the radius. So what you can do? 5 equal 201 square over, and you can solve it with calculator, shift solve, which will give you, solve for x, you will get x, which is the radius, the value for the radius, in meters, remember, because the speed is in meter per second and acceleration is also meter per second square. So you will get the answer in meters. But here they want it in kilometers. So whenever you have to change meter to kilometer, what do? Divide by 1000. If you have to do the reverse, you multiply or times by 1000. So this is the question. I hope it is clear. It's been done here as well. Okay. Moving next. This was the question in the past exam. Two cars are traveling in a uniform circular motion around the circular track as shown in the figure. The first car is moving at a speed v and a centripetal acceleration AC. Okay, they have not given us numbers. So most of us, we get confused when we don't have numbers because we don't have anything to put in the calculator. But keep calm, even if there are no numbers, you have the expressions. So how to deal with this situation? Two cars are traveling in a uniform circular motion around the circular track as shown in the figure. There is Arabic as well, you can go through that. The first car is moving at a speed v. So there is two cars, like there are two cars, one car is moving at the speed v. And a centripetal acceleration AC. So I know the centripetal acceleration of the first car, which is AC. What is the centripetal acceleration of the second car if it is moving at the speed 2v? Now I need to find out the centripetal acceleration of this car. What is centripetal acceleration? AC is equals to v square over r. The radius for both the cars in which they are moving, the circle, the radius of the circle is basically same because they are moving on the same track. But the speeds have changed. So AC or the centripetal acceleration is this for the red car. But for the blue car, or the green car rather, here they have not mentioned, we have just pointed out two different colors. The different acceleration will be, here what is happening, the speed has been doubled because the speed is 2v. So I can say that it will be 2v square over r. Whenever you have a situation like this, put this as AC1, put this as AC2. Now, 2v, 2 square is 4, v square by r. Now, all this term, v square by r, is same as this. So this is equal to AC1, that is AC, what they have given. So I can say that 4 times of AC is the acceleration of the new car. Do we have an option? Yes. 4 times of AC. So the acceleration will become 4 times. Remember, because here it is getting squared. If they also change the radius, then you can make changes in the radius and then get the value accordingly. Question 3. Show how an object moving with a constant speed along a circle can have acceleration towards the center of the circular path. So here we have to represent. Remember, whenever we have acceleration is given by, it's a vector sign, del v, that is the change in velocity over time, how much time it takes. Now, when we say change in velocity, vectorially, it means v final minus v initial. Vectorially. Now, how do we find the directions? So, imagine if this is vector A pointing in this direction. This is vector B pointing in this direction. When I say A plus B, that means the addition of the vectors starting from this point to this point is what we call as A plus B. Touching this part, A plus B. This is the addition of the vectors. But if I have to find A minus B, or let's say B minus A, what will I do? I will first reverse one of the vectors. So let's say if I need to find out A minus B. A minus B. So to find A minus B, what will I do? I will first write it A plus minus B. Negative B means the direction will reverse of that particular vector. Because the negative vector, if this is the vector x, then this is the vector minus x. Exactly same, just the direction is reversed. Now here, A plus minus B. So negative B would be this. This is negative B, minus B. So A minus B or A plus of minus B is basically this. This is A minus B. Starting from the same point again, beating the head of the final vector or whatever it is. Now, we need to show that if an object is moving with a constant speed along a circle can have acceleration towards the center of the circular path. Now, let's try to understand this. If this is the circular motion or this is the object, this is V1, the length of which is same. That means length represents the value. So, or in actual words, we call it magnitude. So here also it is 10 meter per second, here also it is 10 meter per second, but the directions are different. So if this is V1, this is V2. So this one is here V1 and this one is here V2. A vector, remember, can be moved from any place to any place without changing its direction. So this is V2 because velocity has changed. This is V2. If I need to find out V2 minus V1, because when I need to find out delta V is final minus initial. So V2 minus V1. Now this is V2. Minus V1 would be what? Opposite. Exactly opposite. Yeah, it's fine. Minus V1 will be exactly opposite. So if I put minus V1, it would reverse. This is minus V1. This is minus V1. This is V2. Now V2 is here, minus V1 is here. So what I can do, I can basically lift this one up and place it here at this point. If I place it here, V2 would be something like this. And V2 minus V1 will become somewhere here. This is V2, which would come here. This is minus V1. So V2 minus V1 would become starting from this point to this point. Like whatever is the length of this, it is coming towards this point. This is the direction of the delta V or V2 minus V1. Or I can simply say that this is the direction which is entering towards the center. It's like this, pointing in the similar direction. Now this is del V. Time has no direction. I mean, time has forward direction, but vectorially we don't consider it for now. But del V has the same direction as the acceleration. So the acceleration of this particular object which is moving here will be pointing towards its center. If I am measuring it here, it will be here. If I am measuring at this point, it will be towards the center, here, here, and like that. And it will keep going. So the acceleration always points towards the center. In simple words, you can also remember this. If this is vector A and there is another vector B which is starting from the same point like this. So when I have to represent B minus A, it will be B minus A. starting from the original vector, like starting like the one which I am subtracting, and ending to the point here, b minus a. If it was a minus b, it will be opposite, going from here to here. So in this case, if this is v1, this is v2, then this is represented by delta v. If this was v2, this was v1, then delta v would have been opposite. So anyway, this is the representation that even in a uniform circular motion, how an object is always attracted or pulled towards the center, and that provides the centripetal acceleration. Let's see a question if there is any. Yeah, this is a question in the exam. Which of the following table rows is correct about the magnitude and direction of the centripetal acceleration AC of an object moving in a uniform circular motion? Okay. Magnitude of AC. Magnitude means, remember, when it is uniform circular motion, speed is not changing. Magnitude means they are asking about number. So, the value of V is not changing, the value of R is not changing. So, the magnitude of acceleration is constant. Magnitude of centripetal acceleration is constant. So, magnitude of AC is constant. This or this, they are correct. What about direction? So, centripetal acceleration is always pointed towards the center. Direction of AC. So, direction of AC, is it changing? Is it changing? Is it constant? Is it constant? So, what will be right? Because only this option can be correct or this option can be correct. So, changing continuously, because the direction of centripetal acceleration is constantly changing continuously. So, option B should be right. That is the scenario. Moving on to question number 4. Define centripetal acceleration. Define centripetal acceleration. Again, simple situation. You have to find out the acceleration. Like, what exactly is centripetal acceleration? So, a force which keeps the circle, which keeps the circle intact, or basically which holds the body in the circular motion, and it keeps pulling it towards the center. Otherwise, the object will fly off. The explanation of the centripetal acceleration is given, v square by r. Here, let's take a question. A child on a merry-go-round needs 10 seconds to complete one round in a circular path of radius 1.5 meters. So I have a circular path, the radius is 1.5 meter, and the object takes 10 seconds. Time is 10 seconds. To complete one round in a circular path of radius 1.5 meter, what is the centripetal acceleration of the child? We need to find out the centripetal acceleration. We know the time here. This is very important. We don't know the speed. We only know the acceleration is v square over r. This is one equation which we know. Now, we have the radius, which is 1.5 meter, but we don't have the speed. But we have the time. Now, if I know a little bit of mathematics, I know speed or velocity is given by distance over time. I have the time, but do I have the distance? The object is going, or the child is going from here all the way to the circle. Can I find out the length of the circle? That is the circumference, which is 2 pi r over time. Time is t. Now I have everything now, because I have 2, I have pi, I have r, which is 1.5, and time is given. So I can simply put 2 times pi times, when there is no sign, it means times. R is 1.5 and time is 10. From here I will get the velocity. Once I get the velocity, that is the speed, I can basically put it here to get the acceleration. V square over r. So what will be the acceleration? This entire equation, 2 pi r over t square over r. If I solve it, will become 4 pi square r square over t square times r. R would get cancelled. I will have this expression, 4 pi square r over t square. This is the centripetal acceleration. You can remember it as a formula, or completely up to you. You can just change from here and go back to this particular situation. This is the centripetal acceleration. 4 pi square r over t square. Is it t square? Yes. Now, one more thing which you need to think of is, generally they say that if it is one circle, they don't say just time, they say time period, or sometimes they also use the word just period. So you just remember it, and they represent it by capital T. Capital T yani period. They are talking about how much time it will take to cover one circle. Okay, moving next. Centripetal force. If I have the acceleration to find any force, I have the simple expression F equal mass times acceleration. If it is centripetal force, I will use centripetal acceleration. When an object is moving in a uniform circular motion, and remember, force will have the same direction as that of acceleration. When an object is moving in a uniform circular motion with a velocity v and a centripetal acceleration ac, in which direction will the centripetal force act on the object? So, as I told you, force will have the same direction as that of acceleration. So, in the direction of acceleration. That's the correct answer. Apply Newton's second law of motion to derive an expression for the centripetal central force in terms of tangential speed and radius of the circular path. Okay. When we talk about Newton's second law, generally in loosely translated, we say force is equals to mass times acceleration. This is not Newton's second law, but loosely we can say that force is equals to mass times acceleration as the Newton's second law. Now, when we talk about centripetal acceleration, we will have to use centripetal force. We will have to use centripetal acceleration. Centripetal acceleration is given by v square by r. So I can place this value here. I will get force centripetal is equals to mass times velocity square over r. And this is the expression or the kanun or the rule for centripetal force. Mass into velocity square over r. Mass and wazn, how heavy it is, kilos. So this is kilos, this is meter per second, and this is meter, the radius, whatever the value is given. This was the question asked before. Anas connects a tennis ball to a rope and swings it horizontally in a circle, okay, as shown in the figure. Which of the following Anas needs to keep constant to ensure uniform circular motion? If circular motion needs to be uniform, that means the speed of this must be constant. It cannot change. Okay. But do we have the option as speed? The length of the rope and the speed of the ball. The length of the rope only, the speed of the ball only. Nothing needs to be kept constant. Okay. Now, if it is a uniform circular motion, speed needs to be constant, and the radius as well needs to be fixed. It cannot change because the centripetal acceleration needs to be fixed, the value of it. So speed needs to be fixed and r needs to be fixed. So which option can be correct? The length of the rope, which is the radius, and the speed of the ball, which is the velocity. If these two are fixed, then it is uniform circular motion. Question 17, page 146. Identify forces like tension, gravity, and friction that cause centripetal acceleration. So now, in different situations, accelerations will be different. Forces which will provide the centripetal acceleration will be different. For example, assume this wire here. If I start rotating this particular wire like this, so therefore, this wire is getting stretched. This wire is getting stretched, and this stretch of the wire is what we call as tension, because there is a force in this particular wire. So if anything is rotating or like moving in a circular motion, there has to be a force which is acting towards the center. In this situation, it was the wire. So therefore, there was a force towards the center given by the wire or provided by the wire, which is what we call as tension. And therefore, because of that, the object is able to move in the circular path. If this force is not strong enough to bring the object close, then what would happen? This object will fly off. It will go from different locations. That is why this wire has a strength. If I keep moving it very, very fast, the wire will break because it is not able to provide enough centripetal force to hold the object around that particular motion. Because centripetal acceleration or centripetal force is given by mv square by r. So if I keep making velocities more and more, I will require more and more force. Therefore, this wire has a certain strength and then it could sustain only a maximum speed. It cannot sustain more than that. If I make velocity more, I need more force. If I make radius more, I need less force. That is why you must have seen when we turn the cars at a location, like for example, when we are taking a turn and the car is very high, like it's moving with a high speed. So therefore we take a longer turn, we take a longer radius. We don't take a shorter radius, or we generally slow down our cars when we are taking a turn. We slow down so that the centripetal force, the requirement of the centripetal force reduces. And what is the requirement? What is providing the centripetal force here? So the friction of the road and the tires. If the friction is not strong enough, you would not be able to turn so fast because the centripetal force which is provided or given by the friction will not be enough to hold on to it. Tension, friction, gravity. Gravity as well provides a centripetal force in some situations. For example, like if I take this similar wire and I start moving it vertically down like this. So in this case, at a certain point, even gravity is also providing the centripetal force. So it is not just the particular tension. It's tension and gravity, and sometimes it's tension opposite to the gravity. Also, gravity also provides the centripetal force. If this is Earth and Moon is rotating around it, so the force between Moon and Earth is also gravitational force, and this provides the centripetal force for the Moon to take circles or orbits around the Earth. Same way, if Earth is moving around the Sun, so then it keeps moving around the Sun because Earth and Sun has a gravitational force in between, which is the invisible, like which you cannot see. It's like a rope. So basically, it's like this. This is Moon, this is Earth, or you can think of this is Earth, this is Sun. And at this point, there is a force in between. This force is not visible to us, but there is a force which is what we call as gravitational force, and it keeps rotating. It keeps holding the Earth into the solar system or towards the Sun. So this is just an explanation. Let's see if there is a question. A ball on a rope swung at a constant speed in a circle above your head is in uniform circular motion. In which direction does it accelerate? What force causes this? So there is a ball on a rope swung at a constant speed. So I am rotating it continuously, like the example I gave you, and it is holding it, like bringing it together. So in which direction? The force is acting here. Above your head in uniform circular motion, in which direction does it accelerate? It accelerates towards the center. The force is towards the center all the time. What force causes this? Tension. Why tension? Because there is a rope. The rope is constantly pulling it. The ball accelerates towards the center of the circle due to the centripetal force which arises from the tension in the rope. So the answer is given.